We're live. So, hello everyone. Welcome to the Waterhackweek Quasi Cyberseminar. This is the third installment of this seminar series. If you're interested in watching recordings from past weeks, they're available on the Quasi website and YouTube channel. And this webinar will also be recorded and added to those sites afterwards. Before we get started, and while people are still logging in and getting set up, I wanted to talk through some upcoming Quasi events and deadlines. In addition to this cyber seminar series, we have another cyber seminar series going on in February. It's at the same time, 1 to 2 p.m. on Wednesdays, and it's our winter cyber seminar series about growing the critical zone research network. So tune into that if you are interested. Additionally, we have applications open for 2 different workshops right now. The Community Wharf Hydro Training Workshop applications close at the end of February, and applications just opened for the precipitation estimation and analysis of remotely sensed information workshop held at UC Irvine this July. The deadline to apply for that one is March 25th. In addition, we have a one-off webinar in March with National Science, Hydrologic Science, and it'll be involved. You need to ask questions of the Hydrologic Science program managers. One more upcoming deadline is the deadline to apply for the Instrumentation Discovery Travel Grant. That's coming up at the beginning of April. And finally, just to keep it on your radar, the Quasi 2020 Biennial Colloquium will be held in July of 2020. And with that, let me pass it off to Christina, for the Waterhackweek 2020 Cyber Seminar Series. Christina?
Thank you all for joining us today, again, for another Cyber Seminar series, and I'd like to send special thanks to our esteemed panelists who are leading community repositories. And when we developed Waterhackweek, one way that we thought we could bring a community of people together to be working on data science and learning new cyber infrastructure tools that can help you advance your research, we decided that although there's so many different pathways to collaborate, at Waterhackweek, we wanted to have a few shared pathways so we could focus on teamwork and science domain topics in a shared space. And one of those spaces is HydraShare, which you've seen shown around on the different materials that we've shared. And Jerad Bales from Quasi is going to talk to us about what you can do on HydraShare from a community repository point of view. But a lot of the work that we do is going to also involve modeling and hydrologic process simulation and numerical modeling. And the Community Surface Dynamics Modeling System, CSDMS, is a community repository that's really leading the way as far as code and sharing code and developing pathways to create reproducible models through documentation and standardization. In our first cyber seminar series, Nicole Gasparini talked about how that community was such an important part of her team development to develop tools and skills for advancing her science research. As technology advances, the opportunities to build communities and to share resources, to develop new tools, and to create ladders that sort of span across different communities is a constantly changing and evolving field of science in itself. So informatics and advanced cyber infrastructure is a work in progress. It's a result of communities coming together and building shared resources together. So at Waterhackweek, bringing you to the frontier of what's available to help you with your research means that a lot of our work is work in progress. And having a conversation with Jerad and with Greg today about what can we do as a community is an important part of what we want to accomplish. So if we could have, part of our community work is also working with GitHub. If we could go to the slide introducing Madhvi Srinivasan, she is part of our community, and she's leading the piece of building our community on GitHub.
Hey everyone, I am Madhvi. I'm a grad student here at UW, and I got involved with Waterhackweek last year as an event organizer. My primary responsibilities were to maintain Waterhackweek, GitHub, and the website, and also do some data analysis and visualization tasks. And my favorite thing about Waterhackweek is the fact that I get to meet new people with diverse interests and backgrounds, and get a new and fresh perspective on a lot of technical and non-technical things. So yeah, that's pretty much about me.
So we're going to start with Greg Tucker. And I've had the privilege to get to know Greg through working with him on the Land Lab software modeling project for a few years. And as the community is made up of individuals, leaders like Madhvi are helping with our Waterhackweek learning community, and leaders like Greg are really making a difference in the CSDMS community. Greg, do you want to take it from here?
I think you're muted, Greg.
Yeah, thanks, Christina. I think I'm unmuted now. Everybody hear me okay?
Yep.
Okay, so I think in order to share my screen, one of you guys needs to release the share on yours. Because I'm getting an error that says I can't share. Well, there we go. Okay, great. So I'm gonna just say a few quick words about what is this organization CSDMS that Christina mentioned, and what are some of the resources available to it for water science and scientists. CSDMS is the Community Surface Dynamics Modeling System. You can pronounce it with a soft C, so it sounds like systems. And it is an organization funded primarily by the National Science Foundation that is intended to help people who study the Earth's surface using numerical models. So Earth's surface is the domain, and that includes water and sediment and solutes and landforms. It includes people who are interested in engineering timescale problems like floods or landslides or coastal change, as well as geological timescale problems like how does the land take shape, and how do river deltas develop over time, and how do mountain ranges grow. The community that CSDMS supports is somewhere between 18 and 1900 members. It's easy to become a member. You can simply sign up online at the system's web portal. There's no charge for becoming a member. There's about 70 countries and several hundred institutions represented. And that community is served by a small integration facility that's based at the University of Colorado in Boulder, where I'm dialing in from. The integration facility works in 3 areas to support this community, and they are community support, computing resources, and education. So I'll have a quick slide for each of those things to give you the kind of quick rundown on some of the resources that are available. So in terms of community, one of the things that CSDMS does is organize meetings and workshops. There's an annual meeting usually held in May, in recent years in Boulder, Colorado. The next one coming up is this May, the 3rd week in May. This one has a theme of ecosphere and geosphere. So in addition to the usual presentations on various kinds of sediment and water modeling. There will be sort of an emphasis and several talks on the theme of ecology meets soils, marine systems, and the like. Another area of community support is a model repository. So if you're interested in working with a numerical model of some kind of Earth's surface processes, Systems maintains a web portal that is a catalog and repository of currently 300 some odd model codes and tools. These run the gamut from single subroutines all the way up to complete oceanographic or hydrological models. So all of them are freely available. The repository includes metadata, bibliographical information, and either a link to where it's stored on our site or to some GitHub site or external site. So that's a little about community. In terms of computing, as Christina mentioned, one of the things we're passionate about is making it easier to do computing. So I'll tell you about 3 tools in particular. Numerical models can be challenging to work with. And to try to lower that barrier, we've developed a simple Python toolkit that is a modeling framework and is designed to make it possible to run and explore a numerical model directly through a Python interface, even if that model is written in something like Fortran under the hood, using a standardized set of control functions, which also makes it possible to couple models together using simple scripts. So the picture below shows a coupling between erosion model on land and a delta growth model offshore. At the moment, we have maybe 15 or so complete legacy models that are components in this system, written by various members of the community, and we're working hard to add more as time goes by. And we hope soon to have more hydrological models in particular. So that's PyMT. Now, one of the things that researchers often do is build models. Often the model that does the thing you want to do or addresses the science question you're interested in doesn't exist. So to that end, we provide a toolkit called LandLab, which Christina also mentioned. LandLab is essentially a Python language toolkit to make it easier to construct a 2-dimensional, so grid-based numerical model of some kind of Earth's surface process. And it does this by providing gridding tools, so you can create a data object that is a model grid in as little as 1 line of code, populated with data layers of your choosing, and the functionality can be incorporated into reusable components. These pictures show a few examples. So the third thing I'll share is an interface standard. So numerical models can be very idiosyncratic. In our technological world, we take it for granted that technology we interact with, like vehicles, have a standardized interface. So you can expect if you get to, if you rent a truck from U-Haul and it's enormous, or you get into a little smart car, the controls are going to look pretty similar between those very different kinds of vehicles. So CSDMS develops and maintains and helps people with what's called the basic model interface, which is simply a standardized set of control functions, which if a model code provides, that model code can be coupled and added to frameworks like the Python model engine. Okay, last thing I'll say a few words about is educational resources. We maintain educational resources both by and for the community. We run a webinar series in case you haven't had enough of webinars. We have 3 coming up this spring, and in fact this month. These happen to be on software programming topics, version control, unit testing, and object-oriented programming. We also do science topics. There'll be more of those in the fall. Another resource is the Education Repository, which is a whole collection of different educational resources, including lab exercises, various kinds of model animation movie, recorded lectures, images, and so on. So both by and for educators. And then finally, for the first time this summer, we're going to be offering a 10-day summer school on Earth's surface process modeling. This will be a 10-day immersive experience held here in Colorado in August and aimed at early career scientists, so graduate students, postdocs, early career researchers, so on. So that's the quick introduction to some CSDMS resources. I've given here an email contact and the URL. And at this point, I'll stop slide sharing and return it to you, Christina.
Well, Greg, can you, I thought it was just my connection that the slides weren't progressing. So we didn't see.
That's all right.
Okay.
Once we have the recording, we'll add the slides back so that if you're watching the recording back at a later date, you'll be able to see all of the information on the slides.
Okay, thanks.
Oh, so it was just stuck on that first slide, huh?
We're going to put it on Twitter, all of the slides, so everyone can see it and more.
So you ready for me, Christina?
Jared, you need no introduction, but I would like to thank you very much for joining us and to tell us about what we can do with Quasi HydraShare. At Waterhackweek last year in 2019, it was our first year, and we had a Waterhackweek group, and we asked people to publish their data there, and really there was some, I'm really looking forward to hearing from you about why we should do that this year.
Okay, thanks. Yeah, so I'm really, I'm happy to be here. Thanks, Christina, for the invitation. Quasi, the Consortium of Universities for Advancement of Hydrologic Science, is similar in some ways to Greg's organization, but I just want to focus on some of the things that we do that I think might be useful for Waterhackweek. So next slide, Julia. So really, I just want to tell you what HydraShare can do for you. HydraShare is one of the products that Quasi offers and maintains and is continually updating. So HydraShare has a number of functionalities, and one of them is as a data repository, or a repository for anything for that matter, a poem even, a haiku, I believe you might, if you search, you might find a little haiku in there. But you can just drag and drop your files into HydraShare once you've created an account. It's pretty easy to upload data unless you have really big files, but even then those can be loaded through a utility. You can describe your data with rich metadata. And so the metadata requirements are somewhat minimal, but to make your data or your resource that you load into HydraShare more useful, you can load in very rich metadata, including things like how computations were done, where data were collected, methods that were used, and so on. You can control who has access to your data. So you load a resource or data file into HydraShare, you can share those data in some ways like you can share things on Facebook, right? So you can make it public or you can make it private. We can't really make it private on Facebook, but or you can make it public to a group. And so this is a really valuable piece of functionality that HydraShare has. And I'm sorry, I got distracted by a little chat here. But yeah, and so the value of this is that if you collect data and you want to work within your research group to kind of finalize the data, or if you want to get people to review your data, then you can control that. And then when you're ready in HydraShare, you can publish your data or publish your model or publish your haiku with a DOI so that the data are citable and discoverable and in a domain repository, right? So the value of a domain repository is that, if people are looking for water data, they don't have to go to 15 or 20 or 75 different university libraries to look for those data. Next slide, Julia. And then once data are in HydraShare and are made discoverable by others, then you can grab those data and download them and use them, or you can work on those data in HydraShare using scripting tools and apps that are available in HydraShare. You can create collections in HydraShare, and so we have a really cool collection that you can search for on Hurricane Harvey. And so if you just type in Harvey to the search box in HydraShare, you'll get a really nice story map that includes lots of things like flood forecasts, river discharge observations, high water marks, pictures of flooding, FEMA damage reports, storm tracks, and so on, all in one collection that's available to the community. There's also a collection on Hurricane Maria. And then the other functionality that we built in HydraShare is this idea of groups and communities. And so a group might be a group of researchers who are working on a particular project, scattered across the country, but doing more or less the same thing. And so we can form a group in HydraShare. This group can be private or public, but so you keep it private if you want. And so you can collaborate around data, you can work together, you can chat, you can comment, and so on. Or if you have, and so this functionality was built for the critical zone observatories, and so there were 10 observatories, each located in different parts of the country. And so we have a group is a single observatory in this case, and a community is all of the observatories. And so this functionality, as you progress, can be really important. So you might, at Waterhackweek, have a group, and that's your little group of people that are working on a particular project, and the community might be the entire Waterhackweek cohort. You can build apps to operate on your data directly in HydraShare or in the cloud. And so if you look around in HydraShare, you'll see an apps button. So there's some that are there. If you're creative, you can build your own app and load it and use it on data in HydraShare. And then finally, you can share workflows through Jupyter Notebooks with your colleagues so that your data analysis is reproducible. Next slide. And so really HydraShare is built to address the full data management life cycle, and this slide just illustrates that from data collection, data management plan, iterating on your data, archiving your data, publishing your data, and then reusing your data. And this is all built around this FAIR principle of findable, accessible, interoperable, and reproducible data. And so HydraShare pretty much addresses the full life cycle of data. And then the next slide. So this is more for your later use, but these are some links that take you to different places in Quasi's water data services. Mekong Water is an interesting one you might want to explore. So the Mekong River Commission in Southeast Asia took HydraShare, put a new picture on the front end, but they're using HydraShare to share Mekong River data among the 5 or 6 basin states. So HydraShare is open source. It's available in GitHub. If you want to grab it and build your own HydraShare, you can do that if you're creative. So the last slide is just my contact information, and so we'll be happy to, Tony, who's also on the call, or I will be happy to talk to you about any of our services, and of course Tony will be at your Waterhackweek event. So thank you, Christina. That's what I got.
Thank you, Jared. I want to take what we just heard about systems and HydraShare and think about, so in my experience, I feel like there's so many opportunities to collaborate and to use these resources. When people talk about deep learning or, you know, sort of deep investigations that are really just doing more than what would you typically would learn in your university classroom, I want more ladders. And part of those ladders is how Waterhackweek became a learning community, or what we now call a learning community. In the next slide, for context, comparing a community, if you go to the next slide, Julia. Waterhackweek, we are currently calling it a learning community because although it started or was initiated by this idea that we want bigger collaborations, we want to use all of these amazing tools to do more research and investigate more water, make more advancements in our water research in all of our various communities, to learn how to cross those, you know, building ladders across those different platforms, I think is a challenge for us as organizers, to understand how to make everything accessible to you, but to have you not feel overwhelmed by all of the choices. So for example, you know, we started Waterhackweek last year. It's emerging this year. What it becomes is really a factor of who shows up and how we decide to organize it based on a lot of different information. And then we think it'll keep evolving from there. What we have identified is that there's multiple pathways for us to develop our anchor changes. So as a program that NSF is supporting in through their cyber training program to advance the workforce that's able to use all of the cyber infrastructure and community tools, we have identified that we think that increasing the amount of people and the diversity of people who are using this type of cyber infrastructure for water research, we can accomplish it. And we also think there's more questions and convergence in places that we can have bigger collaborations to explore new questions around topics like geohealth or disaster. How do you put your water into all different types of community, your water research into available for other different types of community water research in other science domains outside of hydrologic sciences. That would take, you know, this third anchor change, which includes understanding each other and how we work. So even though we have these big goals that we want, you know, whatever your research is, that's part of those big goals, because we want to support making all of these tools, building these ladders together so you have access to accomplish as much and as deep of research as you can. That's what we're all here for, to support each other with. So as a roadmap in that type of environment, we need a code platform. So we've got GitHub, and Madhvi introduced herself, you know, as the individual that is, you know, helping us take the leadership of our GitHub organization as a learning community. And all of us are working with Madhvi. She probably knows more than each individual, but how each of us as individuals contribute changes the shape of what is that organization. And you know, how do we go from our code, for example, to the code bases that are at systems, for example. We're designing that, you know, as we go, depending on what everyone thinks is the best way to move forward. The data platform, we've picked HydraShare, but there's lots of places you can put data. And we think HydraShare's got a lot of great features compared to other options, but we will develop resources that, if HydraShare isn't the best place for your data, let's find the best place and make sure we can connect it with code to your research and your modeling workflows. We've been asking you to join Slack because we're trying to communicate on that platform. And questions that you have and how you want to build, how your ability to get what you need to advance your research is fundamentally going to be happening a lot on Slack. And if there's other ways that you want to communicate, we're open to all of that. So for example, if you go to the next slide, we are not, as a starting out and trying to build new ways to learn, build these ladders between partnerships, we also partner with really well-established communities like Quasi, like Systems, but ESIP is a different organization that's also been supporting our efforts with travel grants and lots of different services that they offer to support collaborations and to connect us to a lot of the Earth observations, satellites, USGS, NOAA data, all of that. It's an enormous organization and community that we want you to be able to plug into. ESIP is a completely different type of organization than Systems or Quasi or Waterhackweek. But when we all combine and we all know and learn about each other as individuals, we can really build a strong community. Then the next slide, the panel questions that we have here, I want to put back, given that context of navigating a digital space that has so many opportunities and connections, innocently, you can come in and say, I'm going to publish my data on HydraShare. I'm going to publish my model code on Systems. In our professional opinion, these are the best places to publish your water data and your geoscience modeling code, for sure. But there's also things to think about that I wanted to ask Greg. You have worked with a lot of different communities, and there's a lot of different repositories. And how does navigating different communities, does it help your teams, or is it more difficult? Or how do you navigate, like, as the questions get bigger and the teams get bigger, how do you use community to bridge between your modeling experiments, for example?
It's a great question, Christina. There's, in many ways, it's a matter of building from shared experience and expertise. So for example, there's been collaboration between people in the systems community and people in a solid earth community called CIG. And by working with people in these other communities, you learn about resources that you may not have known about otherwise, which I think works well. I mean, the challenge, of course, is that there's the technological landscape is moving fast. When we started Systems and built the repository, we didn't have GitHub. And so we really were a version-controlled online repository for people. Now, many of the functions that GitHub provides in terms of collaboration tools, issue tracking, pull requests, and the whole thing go way beyond what our small project was able to provide. And that's fine. We can still serve an important role by cataloging people's codes and pointing them to the right repositories. So I think one thing that's helpful is to have, so catalog repositories are actually quite important, even if they're linking to other sites, because they provide a kind of one-stop shopping with the kind of information you need to get a feel for the resource that you're thinking of exploring further. I don't know if that answers your question or not, but those are some thoughts.
It does answer my question. I think it explains a lot, because when I go to the model repository, and Systems, it's an amazing library of Earth systems models from so many different people. Those people know, like, they've written the paper, they've made their code available. There's no reason to reinvent those wheels, right? But then I don't know how to connect it to GitHub. So knowing that it evolved before GitHub is actually very helpful to understand. Would you say, as with systems as a community of communities, do you think, what was the best mechanisms that you've seen for communicating across communities about different opportunities to connect while still feeling like you're, you know, how do you manage having a core community that's has shared research focuses, as well as broader communities that keep you connected to all the tools and additional data you might need?
It's a good question. You know, I think in some ways it's a little bit like a diffusion process where there are molecules moving around randomly and encountering one another in collision. In the same way, I think that connecting among communities requires a certain amount of mixing. And we try to promote that mixing in part by doing our meetings and having a focus of a meeting that is around sort of the idea of people interested in using models as part of the scientific discovery process, rather than a meeting around, you know, let's say people who are interested in trilobites or who are interested in river flooding. And so at our meetings, you'll have people whose disciplinary expertise is really wide ranging, but who are united by an interest in computing. And that seems to be an effective mechanism. It also helps to have events that change their theme a little bit. So this year, as I mentioned, our theme is going to be ecosphere, geosphere. So it's going to bring in, we hope, ecological modelers. So that's a whole new community that's in some ways working in parallel and with many interesting potential links to water and soils and oceanographical communities, but don't necessarily know one another. So to get people to forge those links, you have to get the human beings together in the same room, or at least the same virtual room.
On the note that it takes human beings, I think that's a good, I don't know, that's, for me, that's what I come down to and what I really value from meetings. And the expertise and skill and breadth of how you organize that many diverse human beings at systems meetings is really looking forward to seeing it in action in May. At Waterhackweek, we also are working on trying to put together teams of people who are intentionally diverse and all sorts of ways to see what we can all learn from each other. When I scale down to like an individual, I'm in a team or I'm working in a community and I'm trying to get my research out, I still had to like make a choice, like one step at a time, like each data set has to go somewhere. And Jared, I was wondering if you could speak to how to make that choice, knowing like who's operating the repository? How long is it going to be there? How is it, you know, should I have it in multiple repositories? Where do I just publish my data for this paper to get this DOI? Seems like the more one knows about the options, the harder it is to sort of just make a decision, get the DOI, move forward, right? Could you speak to that sort of longer term planning that goes into the decisions of where to put data?
So Christina, this is Tony. Jared had to step out for something, and he asked me to field some questions, so I'll do my best here. I think, say Quasi's point of view as to where to put your data is a decision that should be made by the researcher or scientist, and leaning more towards domain repositories, trying to find the best fit for where your data should live. You know, it's definitely possible to put your data in multiple places, but having one definitive source is probably ideal. That way, when changes need to be made or new releases of your data set are made, you know, people that are relying on it have one place to go to. And as far as making sure your data is always around, you know, nothing is certain, but organizations, data facilities like Quasi are charged with that mission of making sure that these data stay around, and that's actually a large, I mean, that's the primary responsibility of Quasi as an organization. So this is something that we work closely with the National Science Foundation to make sure that we can provide the infrastructure and support to make that happen. And as a researcher or a scientist, I don't know if there's much else you can do, but rely on organizations like that have a mission to keep your data around. The alternative would be to host data on your own, and we know that there's no certainty in that because you know, hosting data costs money, and it'll be up to you to make sure that that it's always hosted and there's money to host it. Does that answer
Yeah,
any of your?
I think it does. Do you have any anything you might want to add to that, Greg?
Yeah, you know, I think it's important that those of us who are working with creating data, creating artifacts of research like model codes and everything else that goes with science, that we can think of ourselves as stewards of science. And what I mean by that is that I think we're in an unusual time in history. If you think back, I don't know, let's say a few hundred years, data was largely printed, and the artifacts were books and manuscripts, and the system, at least in Western Europe and North America, was that material was, it was the job of university libraries to archive that material, and they've done a fantastic job. I mean, the Bodleian Library at Oxford has these vast collections, for example. Today, though, although libraries are still the storage places of books, increasingly the products of science are data sets and software. And our society has not yet evolved a long-term solution to archiving, curating, preserving that for longer than the duration of a research grant or an individual career. And that's where organizations like Quasi make a really important difference, because Quasi is an example of an organization that's independent. It's not a government agency, so it's not subject to political winds. You know, some crazy person comes in and decides that water doesn't actually exist and we need to delete all records pertaining to water. They don't have that risk. The problem is that organizations like Quasi and systems and so on are vulnerable to the winds of funding. And there's not much we can do about that other than as a community do our best to try to sustain you know, community-based grassroots organizations that will try to curate data over the long term. But I think it's also, as individual researchers, it helps to be mindful that the artifacts you create are precious and deserve some effort in keeping them alive, whatever that may look like, whether it's being thoughtful in your choice of a repository, whether it's being careful about, you know, whether it's the choice to use multiple repositories, so there's some duplication or redundancy, or simply your own care and caution in curating your own data with metadata and so on, so that it has the best chance to live on after you.
I really like in my mind, you were talking about like these precious data resources. You know, it really is. People put a lot of heart and soul into their like research endeavors and their creative efforts and teams, and it really is. I think that's a great perspective. If we take that, if we go to the next slide and
think about our responsibility of a data set as a precious resource that we're putting in this extra time and care to add the metadata, choose the right repository, communicate it with the community, right? It takes a lot of effort, and we want to make sure we're doing it right. We want to make sure we know we're like, when you come to Waterhackweek or, in your work as a water researcher, geoscientist, or professional, getting feedback from is actually a really quick way to learn, but it's not exactly one of our professional skills. So this cyber seminar series, we've been inserting professional development topics in public service announcements. So today I wanted to talk about feedback and how probably, if you're like me, if you hear the words, do you want some feedback? That is not, my response is not to expect something positive from the next part of the conversation, right? I just wanted to bring up some resources for people to investigate on their own about how do we build these skills, as a community. To the purpose of feedback is to build experiments, to measure how we're doing, to learn from each other. And in Waterhackweek, it's important to learn as much as possible because we only have 1 week together. So I would describe the context of wanting or needing the professional skills to invite feedback, give feedback, receive feedback in a professional way is something that everyone, I think, works on their entire career. In a meta situation, Waterhackweek, that's our goal, but the team projects, your individual learning goals, as well as the bigger communities that are supporting and cheering on your efforts. That feedback loop really is made up of millions of little real-time loops where we all decide how are we going to react, what actions are we going to take, what decisions are we making, and all of these decisions either benefit each other and ourselves or can distract other people from learning. It could elevate the research and the collaboration, or it could disrupt your colleagues depending on your skill and shared culture of how to critique. So the hyperlink I've provided here is to a colleague of mine, Tim Ferguson-Sauter. He posted his first GitHub repository, his curriculum he built on how to critique. As a graphic designer and art professor, how artists critique visual products, I think is a great, he's got a great perspective on the importance of it, but also the way that they approach the need for feedback in a visual context is maybe something we can learn from. And so I've forked his repository, and inside of our Waterhackweek organization, we have our own how to critique repository. And I hope if you are interested in building those skills, or we work on it, over time, please, you're welcome to contribute to that, and we'll all work on these skills together. So the next slides we're going to go through in the next 5 minutes is just the announcements and some opportunities coming up. At the beginning, Julia told us about the Quasi opportunities coming up. Greg, do you mind telling us about what's happening at Systems in August?
Sure, I can say a few words. So as I mentioned, this is the first of what we hope will be an ongoing series of summer school. I was going to say short course, but it's not that short. It's 10 days, and it will involve 20 participants. The curriculum is going to be about how to do computational work with an eye toward Earth surface dynamics. So it'll be partly programming skills, and especially scientific programming skills, but it'll also partly be case study work with various kinds of Earth surface examples. And I would say for further information, the best person to contact is the first person listed here on organizing team, Irina Ograin. Her email address is her first name dot last name at colorado.edu. It's the Master of Ceremonies.
Thanks, Greg. So I'm just going to note that February 7th is when it starts, but it's open through April 1st. So on the next slide, talking about other opportunities with NEON, February seems to be like the month to be applying for summer opportunities. So if you're new to sort of navigating all of the great opportunities coming up, maybe I'll put February on my marker for February to have all the applications sort of sorted out, because all of these are great opportunities. NEON is the National Ecological Observatory Network. They've got applications due February 17th if you want to join a cohort of early career scientists in a scholarship program. And the conference is in June, Madison, Wisconsin. Another opportunity with an application due February 14th is for a workshop that's going to be going on in May in Boulder, Colorado. Many of these workshops do have travel support as part of their sort of funding structure, so be sure to take advantage of all of these opportunities if it aligns. And you know, from when my personal suggestion is all of these the opportunities, if you can do a couple of these a year and expose yourself to different ways that communities learn together, where are people publishing their data, where are they computing models, you will really have all of the background and experience you need to like make the best choices for your research, and feel confident about how you can share it in a way that will have the biggest impact in the world. The next slide is an overview of the upcoming cyber seminars. We are going to be talking about publishing interactive code. Design Safe is a cyber infrastructure repository that has similarities to both systems and to HydraShare and Quasi, but this cyber infrastructure is primarily used by the natural hazards community and engineers that work on structural infrastructure, like physical infrastructure, natural hazards, landslides, earthquakes, and those types of processes in science domains. So he's going to talk, Tim's going to come to talk to us about how they publish and make compute accessible for running interactive code, primarily Jupyter notebooks. Google Earth Engine is another topic that we teach about at Waterhackweek. Jill Dines is what I would call an example of an outcome of being a Hack Week alumni. So Jill is an alumni of GeoHack Weeks, which were occurring before Waterhackweek started up. And as an outcome, her PhD research, you know, many years later, it was pretty straightforward. It was some work, but in a straightforward way. She's the first person I know of who published code on Google Earth Engine, published it also on GitHub, has all the data from irrigation maps published on HydraShare, and that in her journal article describes all of these different platforms and how they interconnect to be able to reproduce annual irrigation maps and studies of groundwater change due to water management practices across the Midwest, right? So her experience of navigating publishing interactive code for water research is really unique and a really leading approach, I think. Scott Black is working with our HydraShare team, and there's a lot of great new features that we're going to be working on to make available
to everyone at Waterhackweek. How do you package up all of your modeling work into a software archive that you can reuse over time, even when things are changing, or package it up so that you could run it on multiple different platforms, multiple different computers. The next slide is about the learning activities. Madhvi has got a great suggestion here, which I think we can put in the chat box. Also, if you've not gotten started with GitHub or Git, this is our suggestion for the funnest, most easy, accessible description of how to get started with Git and GitHub. Is that first link. And then all of the different learning resources that we develop, we are going to be adding them into this Hack Week Learning Resources repository, which is in our Waterhackweek organization. So as we go forward, we'll be updating and contributing to that, you know, before Waterhackweek, during Waterhackweek, and then after Waterhackweek in March. Does anyone have any questions before we sign off about anything to do with what you've heard today from our panelists? If you want to put questions on Slack for them, we can keep that conversation going. Or if you have questions about learning resources or even logistics about getting onto Slack, please let us know in the chat. So with that, I think we can go through the following slides of our acknowledgements. This year, Waterhackweek is happening March 23rd through 27th, and the East Science Institute at the University of Washington has sponsored and supported our Hack Week, as well as other Hack Weeks like Astro Hack Week, Neuro Hack Week, Geo Hack Week, Ocean Hack Week. It's a community of people trying to explore different ways to learn about the latest in data science and cyber infrastructure. I want to thank our panelists for giving us a view of how this all is connected to communities and how individuals can navigate communities to access all these resources. The next slide is just a reminder about joining Slack with the pictures of us from last year. And if we have any more chats coming in or questions, now would be the time to either chat about how to get onto Slack or to take your questions over to Slack, and we'll keep talking there. The next slide is our acknowledgement for our support from the National Science Foundation and the Cyber Training Program, followed by our slide of all of the sponsors and partners and contributors that make Waterhackweek happen, including this cyber seminar. Thank you for joining us, and we will see you all next week.